Today we're building a Raspberry Pi based ADSB receiver. For that, what you're going to need is a Raspberry Pi. I happen to have this one inside of a fancy case. I'll put a link to this case down and below. Not needed, but super nice to have this case. A Raspberry Pi 4 is in here. You're going to need a MicroSD card to run the operating system on, and an SDR off of Amazon, at least for me, and then an antenna. In this case, I'm going to use a coaxial collinear antenna that I built in a different video, and it's built for 1090 megahertz. You can buy an SDR with a kit that has a kit antenna and it has a short whip and a long whip. You can swap them out. Those will work. Purpose-built 1090 megahertz antenna obviously will work better, but don't think that you have to build that antenna. It's nice, but you don't have to. You can start on the cheap. You can start super easy and get this done and receive some information off the airwaves. So all the information needed for this build is in the description. So bill of material has links to all the components. They're going to be Amazon affiliate links, just so you know. All the instructions are down there, and the gentleman who wrote the scripts that I'm going to be using actually has also a build out of his own. I'll put a link to his build out as well. I'm just making this video because, well, I made a presentation at my local amateur radio club, and they wanted instructions on how to get it done better, easier, and here we are. Because common sense sometimes isn't so common, I'm going to actually put the process of assembling all the physical parts together first. So we're going to start with our Raspberry Pi. SDR and filter. In this case, I'm going to use a filter just because I was able to pick one up inexpensively, and it helps filter out unwanted signals nice and snug together. Don't over tighten it. In this project, I'm going to use a USB extender because the project box that I'm using is a little too small to have it all in line. So I'm just going to extend it there, and then I'm going to put the antenna into the filter. So I screwed the filter into the receiver. I'm going to put the antenna into the filter. And then lastly, I'm going to put my USB extension on the Raspberry Pi. This barely fits inside of this project case. I'm probably going to get a different case for this project later on, but for now this will do. MicroSD goes into the Pi. Power goes into the Raspberry Pi. I'm not going to get there yet because we still have to image this card, and at the end we'll power it up. Okay, so for now, that's the physical assembly minus putting the SD card in and powering it up. Okay? So now that you have all the components ready, let's go ahead and get this thing built. I'm not going to build the actual Raspberry Pi physically in front of you because, well, there's videos already around for that, and I'm sure there's a video around for this, but this video is built primarily for you. So here we go. We're going to go to let's search Google for Raspberry Pi OS, and we're going to go to raspberrypi.com/software, and the easiest way to do this is going to be to download the Raspberry Pi imager. So I'm running on a Mac, so we're going to download this and save it. And another thing I like to do is I like to download the OS by itself. So that's what images the MicroSD card. This is the actual OS. You can download this with the Raspberry Pi imager. So any one of these will work. I like to use the Lite because I don't need the graphical user interface on my Raspberry Pi. And the ADSB script is built around the 32-bit version of this. So I'm downloading the 32-bit version of the OS. So next, while the OS is downloading, I'm going to mount up or install the Raspberry Pi imager. And on a Mac, it's as simple as mounting the DMG and then clicking and dragging. On Windows, it's you know, I haven't done it on Windows, but I imagine it's a download and unzip. So now that that's over there, I'm going to close that, and I'm going to launch that software. And on a Mac, the first time you load it, it's going to ask you, are you sure you want to open this? We're not sure about it. I just downloaded it, and I know it came from the reputable site, so I'm going to tell it okay. And you're going to get this window that opens. This window is going to look similar in Linux, and it's also going to look similar in Windows. So we're going to choose the OS. Since I have already downloaded it, I'm going to select custom image from your computer. And we're going to go to downloads. So now we've selected it. I'm going to pop in the MicroSD card for my Raspberry Pi. So now I'm going to insert my MicroSD card into the reader. So now we're going to tell it what card. And before we hit the right button, we're going to click on the sprocket here. I'm going to tell this no. And we're going to make some settings take place for this Raspberry Pi before we even start it, right? So we're going to change the host name to, by default it'll be Raspberry Pi, so you can leave it alone if you want. If you want to find it on your network using that name, that's fine. I want to call it, so let's see, ADSB receiver. Let's just ADSB rec for receiver. Enable SSH. Use password authentication, and then set the password on the account Pi to something. We're going to call it airplane. Let me make sure that I type that in there right. Airplane. And we're going to configure the Wi-Fi. I have a separate network for this stuff in my house. And then we're going to hide the password because I don't want you guys seeing it. Even though it's an IoT network that has nothing on my real network, we're going to set the Wi-Fi country to, for me, you do whatever you need to do, but I'm going to set it to US. And of course, this takes forever to scroll down. And typing the letter U does not take you to the US, as you might expect with other things. And then we're going to set the locale. I'm in Indiana. Keyboard layout is the US. I'm going to skip the first run wizard because this is really what I care about in the first run wizard. And keep in mind that I'm doing this for the light OS. If you want to have the desktop OS, you're probably going to want to run the first run wizard, but hey, you do you. And we're going to save those settings, and now we're going to write to the card. It's going to prompt me, are you sure you want to erase this? Yes, I do. And it prompts me for my password. And on this system, it takes 3 minutes, so I'm going to speed this up for the sake of brevity. So now it's telling us the write is successful, and we're going to click on continue. So we're done with the card. Let's pop this sucker into the Raspberry Pi and get started with it. So bear with me on this one because I don't have one of those fancy HDMI capture devices, and I'm having to use my camera against the screen. But I'm going to boot the Raspberry Pi immediately after imaging it. We're going to see the boot up process. And the first time you boot, it's going to take a couple of reboots before it gets settled in, because it has to do all the configuration that we made when we were imaging it. So if this is happening to you when your first build, don't worry, you've done nothing wrong. This is perfectly normal. Now that we're at the login prompt, I'm sure you saw it there for a minute before the other two lines came in. Starting services and whatnot. We're going to wait for all this to get its thing done. And we're going to log in as the user that we had at the setup, which was Pi. And I set the password to airplane. And this is as much as you need to know about the command line of the non-graphical user interface. Log in, and you're going to type in IP address. And this is on my guest wireless network, or on my IoT wireless network, and we're going to see what we're looking for. In my case, is this WLAN 0 and INET and the IP address. So this one is 10.254.91.13. And we're going to use that information on the next step to get connected into this Raspberry Pi remotely. So now that we've booted the Raspberry Pi and gotten its IP address, next is we're going to remote into it from within our network, and we're going to use a tool called SSH. This is built into Mac OS and into Linux. On Windows, you're going to have to download an SSH client. I use PuTTY. I will show you PuTTY in a minute, but for now, we're going to stick to my Mac setup. And we're going to type in SSH pi at 10.254.91.13, which was the IP address we got from before. And it's going to ask us, do we want to save this fingerprint? We're going to say yes. And we're going to type in the password for the system, airplane. And now we're connected into that Raspberry Pi. If you want to see, you'll see that the prompt changes here to Pi, which is my username, at ADSB rec. Right? That's what we called it to begin with, ADSB receiver. So, and we can also say IP address, just like we did on the actual window, the actual screen for it earlier. And we see that we have the same lines of information as we had before. And the one that we really cared about was this one, right? So next, we are going to go to GitHub and go to WiFi repositories. I'm going to have a link to this on the description. So all the information you need for this video, again, is down in the description. So if you're asking yourself, I don't want to type all that in, well, just go to the description and copy and paste it. So now we're going to install ReadSB and tar1090 all in one hit using WiFi scripts. So we're going to go to WiFi's, and I hope I'm saying that right. If you know how to say that, and I think that's a German last name, but I could be wrong, I don't know. Let me know how to pronounce it. We're going to go to his GitHub, and we're going to go down to automatic installation for ReadSB. We're going to copy this command line. We're going to go over to our Pi and paste it. So all you have to do in Mac OS is right click and paste. In Windows, you just use, if you're using PuTTY, all you have to do is right click and it will paste it automatically, and we're going to hit enter. This is going to download the script and download the requirements and install it all in one hit. Takes a few minutes. Takes about 4 minutes on the Raspberry Pi 4, which is what I'm using here. And I'm going to speed this up so that you don't have to deal with all that wait. So now the installation is complete, and you will see down at the bottom it says error with ADSB read SB permission issue. Please perform a reboot using this command, and then we're going to do it. So sudo or sudo, depending on who you're talking to. And we're going to reboot our Pi and wait for it to reboot. And once we reboot, we are going to connect to it again and see if it works. So the Pi has rebooted, and even though we don't have an antenna on it, it won't receive anything yet. But at the very least, I know that that process is done. Let me shut it down and put an antenna on it. So our Pi should be rebooted. Let's see if we can connect into it. We can, and then now that we have an antenna on it, look at that. We have a couple of airplanes being received already with enough information to plot them, and then a few more that we don't have enough information for plotting them. Keep in mind that I'm in my basement, and that should give you an idea of how well this antenna actually works. If you make yourself a Coco, which I have a video about, I'll link at the top there with the card. It's really easy to build, and as you can see, it works even in a basement. Of course, it's going to work much better outside. So let's go back to the Pi configuration itself. Let's add a couple more things to our configuration. So we've installed readsb and tar 1090. Let's go back to Weedhoff's scripts. We're going to add the automatic gain configuration. The SDR has a gain setting on it, so we're going to let Weedhoff read the stats from it from the Raspberry Pi and then adjust the gain on the radio based on what it gets. So that installation is done, and then run this every 2 minutes. Well, we're gonna first to show that it works. All right, we know it works. Now we're gonna do this later so that it actually gets a baseline for what gain it needs to be running. You want to do this command after you have your receiver where you're going to keep it, because if I run this command right now, it's going to base the gain on what I have for reception in my basement, which is not going to be anywhere near what I'm going to have for reception where I put it finally, which is going to be outside. One more thing that we're going to get from Weedhoff is graph 1090, because I want to have performance graphs on my Raspberry Pi receiver. And we're going to copy the installation line and go back to the Pi itself. Paste the installation line. Again, going to download the script and then process all the commands and the scripts all on its own. You can do all of this by hand if you want to. I happen to trust his script, otherwise I wouldn't be running it willy-nilly. But as you can see, it's going to install all the requirements and get it running for us. So the installer script for graph 1090 is done, and it tells you where to get the graphs. So we're going to go there. Even though there's not going to be anything there right now, at least nothing of importance, because we just installed it. There's nothing there, right? But at the very least, we can see that it is installed and that it generated the first set of graphs for us. All right, so the last thing we need to do is configure where we are on readsb so that it knows where to put our map, number one, and number two, where to tell the system, the other systems, if you will, if we're going to feed this to the internet, which some of you will, some of you won't, where we are so that it knows that the reception that we're receiving from airplane whatever is based on our location. I'm going to use the Columbia City Post Office as the location for this one, just for the sake of having some numbers. I'm not going to put my actual grid coordinates on here. But if you go to maps.google.com and just right-click on your home or where you're going to have this thing, right, this receiver at, one of the things you're going to get are these grid coordinates. So copied it to my clipboard, highlight, we're going to go back to the command line for the receiver, and we're going to type in sudo or sudo. You say potato, I say tomato. And then we are going to tell readsb where we are. Readsb set location. And then we're going to give it the grid coordinates for where we are. We're going to backtrack over here for a second and get rid of that comma. When you copy it from Google Maps, it's going to have that comma. You don't want that comma. I think that readsb only cares for the first 6 characters after the decimal, but I could be wrong. So I'm just going to leave that on there. And now readsb knows where we are. And with any luck, if we reload this page, it should have a dot. There we are, based on our location. Keep in mind that I'm still in the basement. I'm going to move this outside in a minute and then come back to this to show you what we're getting in terms of reception. But understand that I'm giving erroneous information to the network right now because I'm telling it I'm inside of Columbia City, when in reality, I'm not inside of Columbia City. So the closer you get this dot to the real place, the more accurate it's going to be. And it's also going to feed the right information for multilateration, which we haven't talked about. Back to the Raspberry Pi. I have a couple of things that I like to do on a daily basis because I like to keep this specific software very close to being up to date. So I'm going to tell the system to self-update this software every day. I'm going to do that by typing sudo crontab -e. And crontab in Linux, if you're not familiar, is a scheduler. You tell it what to do when, and it'll do it. In this case, I'm going to, this is the first time I've done crontab on this unit. So I'm going to use nano, and I'm going to come down here at the bottom of the crontab file. And it's going, and the format it's looking for is what minute of what hour, right? And then day of the month, what month, day of the week, and what command. So since I want to do this every day, I'm going to do this at 15 minutes after midnight, midnight being hour 0. And then I'm going to give it wildcards for the rest of them, which is asterisk. So it's going to be an asterisk, a space, an asterisk, a space, an asterisk. And then I'm going to give it the command for installing this. So we can go back to Weedhof, and we're going to just copy this part. We're not going to copy the sudo or sudo because it's not needed inside of the cron tab. We're going to paste it, and we're going to do the same thing at 30 minutes after the hour every midnight. For tar 1090, we're going to get rid of the sudo or sudo. Again, potato. That's for you New Englanders, I guess. Terrible New England accent, I know. And then, lastly, because I like my Raspberry Pi to have a little rejoice every day, I'm going to tell it to reboot every day at 1 o'clock in the morning. So we're going to go to 0, 1, asterisk, 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 and reboot. And we're Control X will save this, we'll exit this, and you're going to see that it's going to ask you, do you want to save this? And you want to say yes. And now your cron tab is installed, and it's going to update Graph 1090 15 minutes after the hour. It's going to upgrade tar 1090 30 minutes after the hour at midnight of each one of those, and it's going to reboot at 1 o'clock in the morning so that every day starts fresh. And here we have one of my live units, and as you can see, it is receiving 73 aircraft with 68 of them with positions. about 800 and some odd messages per second. These are all the aircraft in the area. And let's see, the farthest one right now is 148 knots away. Nautical miles, I should say, not knots. Probably this guy. Let me verify. If we click on it, yep, tells us that's where it's at. It's going into Milwaukee, probably. We're going to, no, it's going over Milwaukee. Keep in mind, I'm in Columbia City, Indiana. I'm a long ways away. That's all I have for this one, folks. Remember, all the instructions are down below in the description. The links to the hardware that I would use is also down in the description. And have fun with this.